For those of you that don't know who I am or my background, I've been selling machinery since I was 21 years old. I opened up a small tooling company back in 2001, and that was in Miami, Florida. And I basically went around knocking on doors, selling small granite blades and sandpaper to shops. I was very lucky that within 7 months, somebody heard me speaking Italian on the cell phone and asked me to find them a used Italian bridge saw. $30,000, I made a 15% commission, and I was hooked on selling machinery. What a headache. When you have a problem, you're gonna hear about it if you're selling machinery, for sure, at all hours of the night, every day. And that started me on a career where today Poseidon has over 650 machines all over the United States, edge machines, CNCs, all different CNCs. We used to make 5-axis CNC saws and routers, and we currently only have a small product lineup because we came up with a solution over these past, my 25 years in doing machinery, something that is called the hybrid cycle. Now I know some people have heard that, you've probably seen some of our marketing, so I was curious, instead of me sitting here and talking for a long time, who here is not really clear on what the hybrid cycle is? Has everybody heard of it or know? Or does anybody not know what it is? Okay, well, what the hybrid cycle is, and I'm just going to give you a quick run through here, is currently right now, and in this video you're going to see a process where what we do is we load the slab one time into the machine. And I'm just going to pause here for a second. What's been happening in the stone industry is what we call in manufacturing split processes, where we're cutting on one machine, then we're moving the pieces over to another machine. In that in between, there's what we call work in progress carts, which I'm sure you guys are all familiar with. Takes up a lot of real estate in the warehouse, in the facility. And what we decided to do, over the years, I would always ask my customers, what could we do better? How can we make this a better machine? And people would say, well, it would be great if you could put the slab into the machine one time, like a microwave, and the pieces come out finished or done. Essentially, that's what we did. What we did was we wormholed the whole process from start to finish of doing what we call in manufacturing split processes to a single process. The hybrid cycle is the first single process that has ever existed in the stone industry, where we put the slab one time upside down on vacuum pods. And the way that the process works is, what we do first is we cut the sinks out with a finger bit. Now, common reaction I get from my customers is, as soon as I say finger bit, the wind goes out of their sails, because we're all used to very slow finger bit rates, super Z rates, and in general tooling speeds. The CNC router is way more inefficient than cutting. People love saws because we can cut a lot, but we gotta fabricate those pieces. A CNC router, I believe the normal rate is about 200 square feet per shift, or we have a lot of people doing things by hand. Well, what we decided to do was eliminate that, make the tooling times faster. So one thing that we also have a concern about is those tooling speeds, but how come the T-Rex can push a finger bit at minimum 24 inches a minute, 3 cm quartz and granite on a sinkhole cutout? Well, it's simply because we took the construction design of a machine from the dimensional stone industry, a 5-axis router that's used to carving, working with big blades, doing profiling and doing dimensional stone type of work, and we applied it to countertops. What did that do? The carriage on the T-Rex is 5x the weight of a 3-axis router or a 5-axis saw on average. Our spindle is 35 horsepower direct drive. So those things enabled us to do double stacking of tools with no problem, no flexion. All of our machines since 2014 that we've been making 3-axis routers, we don't make them anymore, and the T-Rex, all the machines across the United States double stack the tools. And it works great, and the quality is beautiful. So what you're seeing here in this video is the way that we cut the sinks out first in the hybrid cycle process. We cut the sinks out first when the slab is whole. So for the first time, we have a situation where the whole slab is being suctioned to the table. What does that create? That creates a very reliable way to make sure your pieces don't move, because you might have some vanity holes in that slab. And if you have vanities, typically you don't want to cut them ever on a router because the finger bit's slow and the piece is going to move. There's no surface area for the cups to grab. So what we did was we put everything on one slab, sinks get cut first, makes the most sense, then we go to the cutting process. What we wanted to do is not just condense all the steps in this process, but we also wanted to make every part of the process of fabricating a countertop easier and better quality. And my favorite, the most foolproof, which I used to say idiot proof, but now I have to say foolproof. So what's going on here is, how are we elevating the quality of cutting? Everybody's cutting on bridge saws or saw jets. The table is slightly unlevel. When the table is unlevel, you have a different type of stress on the blade and the arbor of the motor because the pieces are lopsided. And also that's why on backsplash machines, the motors oscillate, so they can try to cover that discrepancy or crookedness of the cut. When we cut on vacuum pods, two magical things happen. Number one, throw out all of the work you guys have to do on the weekends, refilling concrete tables and remilling them, or having to pump out tanks, having to replace metal slats, etc. All of that labor and maintenance on cutting substrates goes out the window with our process. But not only that, is that for the first time ever, we have a beautifully perpendicular blade cut on a perfectly level surface. So that means that our blades last longer, there's less stress on the arbor of the motor, we have a much more better quality edge that we can run through an inline polisher or a backsplasher. As well as, we're happy to say, you don't have to mess with a wrench and a hammer ever again to replace your blade. All of our blades on our cone are on cones. This is the second part of the process. We cut everything up. So now the cutting process has completely finished after the blade runs through. When we're cutting upside down, a big apprehension is everybody says, well shoot, if I cut upside down, I'm gonna have a really chipped bottom. How many people have thought that? Right? Makes sense, that's what we're used to seeing, okay? Well, what happens is we think that because all of the waste is going into a table where it's trapped, into a concrete table or a substrate, and then it's jettisoning the waste out the backside, so it's chipping or sandblasting the bottom of the material as the blade is traveling. And so what we're doing here, and you can see this in the video, all of the slurry and the waste goes straight down to the table with the water. And so there is no chipping upside down. The other nice thing about cutting upside down, what did this give us? This gave us the ability to cut miters in a very foolproof way, whereby simply being on vacuum pods, we eliminated the two of the headaches with miters, which is what? Is the table level? Is the material thickness changing? Because now the CAD/CAM software is calculating where the blade comes in on the top. But if my level is not good, my measurements are no good. So this causes processes that are very inefficient, like probing, right? We're wasting a lot of time probing. We still don't get perfect measurements when we're cutting polished face up. Cutting upside down, we're able to get perfect measurements because as long as our blade diameter is set correctly, when the blade comes down, it's calculating where to land on the bottom of the material. So now if I have a 70-inch long island and it's 30 inches wide, it's perfectly 30 inches. Now, if it's off because the operator, whoever is off a little bit on the blade diameter, or maybe it wore from the job beforehand, if it's off by 1.5 millimeters, at least the whole measurement is consistent, which makes my lamination way easier. So that's one of the things that we solved cutting miters. It actually became, you could argue, the best way to cut miters. Going digital with one chess move. The machine does the whole process with one work file, one program, and one process, in that I am putting the slab into a machine one time, and I am eliminating work in progress carts between two types of machines. And I'm eliminating all of the manual labor associated with that, and I'm also eliminating all of the possibilities of pieces breaking by handling them more. 250 square feet is approximately what we get on a single jumbo table T-Rex. Our jumbo tables are 160 by 120 deep, which means that I can fit any jumbo size slab and I can miter the whole envelope, no problem. And if my slabs are less than 119 by 78, I can rotate them 90 degrees and I can process 2 slabs at the same time, which is even more efficient because I save all the tool changes on the second slab. And this is a machine processing 4 slabs in one machine with one operator. These were vanities that they didn't run the whole process of fabrication. They ran them through the inline, the front face, but we opened the holes, super Z'd the sinks, cut everything up, and it took a total to process 4 slabs just to do that, about 2 hours. And as you can see here, as they unload one table, they're reloading the next. So the machine works nonstop. It's the only machine in the industry that's capable of having what we call 100% utilization in manufacturing, where it works nonstop, while doing the most efficient, fastest process to make a countertop. As we were mentioning before on the miters, the imperfect level and the slab thickness vary. Number 3 is miter strips are very fragile. They're wider on the top, so they're top heavy. When you have the last exit cut of the blade on a miter strip, it wants to topple over into the gap, which causes breakage. It also happens to be a process by that miter strip wants to move the whole time. What we do is we cut those miter strips upside down on quartz blocks. Our system is with vacuum pods, quartz blocks, and rubber blocks to have support to hold what we call accessory pieces. Vacuum pods go under main kitchen pieces, and accessory pieces, which are miter strips, lamination strips, or backsplash, they're held underneath by quartz blocks or rubber blocks. And so this creates a situation where for the first time the miter strip is actually polished face down, and it's very stable where it does not want to move. Here we go. So you can see here, this is a miter strip having been cut. And this is an upside down. Who here jumps for joy when they have to do an integrated miter sink? Okay. I mean, you could charge 3 times more, but it's probably going to take you could have done 8 easy jobs for the time it takes you to do that. So what we were able to accomplish by going upside down is that when we cut miters in an inside L situation or a mitered sink, our software will bring the blade down where the bottom of the blade will go right up to the 90-degree corner, and the top of the blade is going to overcut in the corner. This is going to give us separation, perfect measurements, perfect perpendicularity of a rectangle, if it's all mitered, as well as a very clean cut. And the blade is going at about 80 inches a minute. We have speed, quality, and an upside down miter that leaves it perfect. Does anybody have any questions so far? Yes?
So you have a perfect level, good cost, everything straight, not moving, so when you cut porcelain and Decton, probably you have much less breakage than any other jet would be slot.
Yes, so what we're seeing now, and we're testing, and the thing is that we're in a period of time now where, because this is a new process, we're evolving also with the tooling. Every year, we're getting better and better tooling to get better and better quality on harder materials like quartzite and porcelain. So if the porcelain is 5/8 of an inch or thicker, people are cutting it on vacuum pods. We noticed that also the porcelain has this weird feature, no matter whether it's Decton or other porcelains, that when you cut with the blade, it chips a little on the bottom no matter what. And if you go upside down, same thing. So we're cutting that polished face up because it's usually always mitered anyway. We cut it polished face up on the vacuum pods, and we're cutting at 80 to 120 inches a minute, but with a really nice quality. We're working on a blade that is leaving a very nice finish, the same as the top. To try to get that to be upside down on the pods. Anything less than 5/8 of an inch thick on porcelain, because there's a lot of tension in it and it's very skinny, we just cut that on the mats. So conversely, if you don't want to work hybrid for whatever reason, a certain material, and you want to go back to what we call traditional, which is cutting polished face up, we throw mats that are within a millimeter thickness of each other on top of our CNC bed, and you can cut traditional as well. And we have the fastest cutting speeds cutting traditional on top of mats as well. If you want to do that, and the material thickness calibration is really good, your level is pretty much perfect. It's probably arguably the best level you can have anyway, because it's on a CNC bed. But yeah, that's the only material that we sometimes recommend to cut it on the mats if it's less than 5/8 of an inch thick. Everything else, 3cm quartz, granite, quartzite, you want to go hybrid. It's the best way. Thank you, Sol. Anyone else have any questions? So the other thing I wanted to mention about this process really quick is this is also, I know I just mentioned everything and how fast and good it is in the shop, but from a management standpoint, as a business owner, what this means, taking a step back, is a lot of people have, because they're testing out what is the best machine for my process, what's the best brand. Some people have multiple saw jets, multiple CNC saws, multiple routers, okay? What this means is that if you start with our process and you commit to the T-Rex and the hybrid cycle, once you turn completely over to our process, you only have one CAD file and one program to worry about for the rest of your career. In other words, my management of my shop is much easier. My SOPs, my job descriptions in my company have streamlined now. Currently, it's very chaotic to ask a production manager to be really informed on every single model of machine that they have in their shop and how that machine's programmed, because typically every brand has a different type of CAD cam to learn, a different procedure, different type of vacuum pods, different type of feed rates. And so in order for them to really manage that shop, they'd have to learn to manage the operators better, the specifics and the nuances of every single type of machine. That is a very tall ask. But now with this system, this is a very easy ask. It's very easy to manage just one machine, which means that also the operators in your shop, they're all learning together if they have multiple T-Rexes. You also have a great redundancy factor that's never existed before, because you have a machine that not only does it cut the fastest, route the fastest, and do a process which is the fastest and most reliable, but you have redundancy. If you need more cutting, all your T-Rexes can cut more. It's like having a military force ready to go. If you need to route more, all your T-Rexes can route more. If you get a bunch of miter jobs, all your T-Rexes can miter. So from the standpoint of management, this is a redundancy dream as well, because your job descriptions get simplified, your SOPs get simplified, your program maintenance and keeping track, all your CAD overhead and programming overhead goes down to half. And if you want to scale and open up another location or start buying other shops, pretty simple, just more T-Rexes. It's easy to duplicate the system. So these are things that I just wanted to share. Couple last things. Our service department now, we have over 120 videos only on our CAD/CAM programming. We have an online school for our CAD/CAM programs, like a 4-hour online course, just like driving school. For those of, I'm sure nobody here's gotten a ticket. And we also have virtual reality, which we are here to showcase in between if somebody wants to check it out. We began to build out a virtual reality experience of our machine to train operators, because we felt that one of the biggest problems our customers have is losing operators. And if we can begin to train them in an office, in a virtual reality experience where they are more engaged and the concepts of the machine and how to run it are much more easily visible, because it's almost cartoon-like. It's much simpler, it's much more comfortable for learning, and we're doing it in Spanish, English, and Portuguese. So just wanted to share a few of those quick things with you. Thank you guys very much, appreciate it.
Thank you.